Okay, so we are going to graph a single cycle of y equals 2 sine 3 theta plus pi minus 1. So this is an example that has all of the transformations in it. Remember the ones on the outside? Ones on the outside, these are our vertical, and they will affect the range values, or the y values, right? The ones that are on the inside, these two, these are horizontal, and will affect my theta values or my domain, right? But I'm just going to stick theta right there. All right, so we can work with them separately, right? I'm going to do the range first. Range usually seems pretty simple. I generally don't have to deal with any fractions. So I'm going to get my list. I'm going to write out what the original values were just so we have a something to go off of. So the original parent function of sine, theta is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And my y values are 0, 1, 0, -1, and 0. And so my transformations are going to be based off of that. I want this to go away. I don't think it's going to. That's okay. All right. So I'm going to deal with my y values first, my range. And so look at what it's telling me to do. The number that's out front of my function, I'm going to multiply by that value, and then either add or subtract this value. So in this case, I'm going to subtract 1. So first, I'll multiply, and then second, I'll add or subtract. Okay, so my new values, we'll get to theta in a minute. Alright, so my new y values, I'm going to multiply by 2 and subtract 1. So I have 2 times 0 minus 1 gives me -1. And then I'm going to multiply by 2 again. So 2 times 1 minus 1. 2 minus 1 gives me +1. And then same thing. 2 times 0 minus 1 gives me -1. 2 times -1 minus 1 gets me -3. And last, 2 times 0 minus 1 gives me -1. So there we go. I have my new y values. I can make that go away. There we go. I have my new y values. And so let's move everything out of the way. We good on that? Yep. All right. So let's find the theta values now. Remember the values that are on the inside of my function, these are the horizontal ones. I have a value in front of theta. So before I know what my horizontal shift or anything like that is, I have to factor that value out. So I'm going to come over here, I'm going to rewrite this. Y equals 2 sine. I'm going to factor out the value in front of theta. So 3 parentheses theta. And I'm dividing by 3, right? 3 theta divided by 3 gives me theta. Pi divided by 3 gives me pi over 3. And don't forget my -1. There we go. All right, so now I know what my phase shift or horizontal shift is. The value right here. This is my horizontal or my phase shift. Remember, it is the opposite. So this tells me I'm going left pi over 3. Also remember that your horizontal or phase shift is your starting point. Right? So I'm going left pi over 3. So my starting value is negative pi over 3. I got that. Now to find the other 4 values, I have to compute the period and divide it by 4. So my period comes from my b value right here. So I'm going to come down here towards the bottom of the page. My period is 2 pi over that b value that we factored out. In this case, that value is 3. I can't simplify that, so that's my new period, 2 pi over 3. Okay? What this tells me is that the length required to complete a single cycle will be 2 pi over 3. So I squished or compressed this sine graph, right? When I graph it, it's not going to be as long or as wide as the original function. It's going to be squished. So how do I find the other 4 points? To find the other 4, I'm going to take my period and divide it by 4. Right? Divide it by 4 to get the other 4 points. So I'm going to do 2 pi over 3 divided by 4. And however you remember to divide fractions, KFC, copy change flip, KCF, whatever it is, multiply times the reciprocal. So this gives me 2 pi over 12, which is pi over 6. So I'm going to add this value to my starting point over and over and over until I get my other 4 points. So fractions, you might want to brush up on them a little bit. So negative pi over 3 plus pi over 6, I need a common denominator. Negative pi over 3 plus pi over 6 gives me negative pi over 6. And then add pi over 6 again. So negative pi over 6 plus pi over 6 gives me 0. Then I'll take 0, add pi over 6, gives me pi over 6. And one more, take pi over 6, add pi over 6. I get 2 pi over 6, which is pi over 3. So right here, these are my new values, my new theta values. Okay, so once I have my values now, I can go ahead and graph them. And I am on the negative side, so I have negative pi over 3, negative pi over 6, 0, pi over 6, and pi over 3. And the highest I go is positive 1, and the lowest I go is negative 3. So 1, 2, 3. And now it's just a matter of plotting the points. At negative 3, I'm at negative 1. At negative pi over 6, I'm at positive 1. At 0, I'm at negative 1. At pi over 6, I'm at negative 3. And at pi over 3, I'm at negative 1. So connect my dots. And there's the graph of my transformed sine function. I do want to list out all of the attributes that I know, what all 4 of the transformations tell me about my function. My amplitude, the absolute value of the number multiplied out front. And recall, if I have the center, so the center on this graph, you don't have to draw this little imaginary line, but this is the center. My graph does revolve around that center. And the distance between the center and the highest point is 2. The distance between the center and the lowest point is 2 as well. But you can easily just find it by the number multiplied times the function. So my amplitude is 2. The period, we already computed. It was 2 pi over 3. My horizontal shift, or my phase shift, we said was what? Where are we going? Left pi over 3. So when you describe your phase shift, you need to have direction and a value, right? So I'm going left pi over 3. It's not going to be sufficient to say negative pi over 3 or positive pi over 3 or just simply pi over 3. It needs to have direction and a value. So my phase shift is left pi over 3. And then lastly, my range. the range of the function, the lowest point is -3. Lowest point is -3, and the highest point is +1. So my range is -3, +1. And so now I have my graph, I have all of my values, and there we go.